Everyone look at it. Yeah. So don't forget where we are still dealing with. We are still dealing with our menstruation. So we are now starting to calculate the formulas. You know what I'm saying? So we will apply those formula in solving any question that has to do with menstruation. Now look at this circle now. From here to here is called diameter. What do I call it?
Diameter.
That is the half of a circle is called what?
Diameter.
Diameter. Now, the half of diameter is called the radius. The half of diameter is called what?
Radius.
Good. So, diameter is equal to what? 2 radius. Look at it. Don't forget this formula. Diameter is equal to what?
2 radius.
Diameter is equal to what? 2 radius. Are you understand what I'm saying? So why to get radius, what are you going to do here? According if you are as a mathematics student, you divide both sides by what? By 2. So radius now is equal to diameter over what? Over 2. Don't forget this formula. Are you understand what I'm saying? So through that formula, we get the formula for an arc. What I call it?
An arc.
Formula for an what?
An arc.
For an arc. Are you understanding? So this circle, from the half of a circle is called diameter. Half of a diameter is called radius. So we give formula for diameter and formula for radius. Now if you look at this now, look at this place very well. I got another circle here. This one is now, the line did not pass through the middle to divide the circle to half. It's just the little part of it, the downside of the circle. It is called chord. What do I call it? Chord. Now this line, the circle that passed through it like this, from here to here, is called the arc. It's called the what?
Arc.
For example now, you see some buildings, they will draw this arc like this. It will like this. I understand what I'm saying. You see something that, like let's say a door, you see that like this.
Yes.
Or a rainbow, you see something like this. It's called an arc. It's not a total circle. You understand what I'm saying? Neither is it a diameter. Are you understanding it? Yeah. Just a small part like this. It's called an arc. And you can derive several arcs. Let me show you another one. Look at this point, and this point, another arc. 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 What have we just done now? So we've divided this arc into what? Polygon. How many sides? Poly means 5 sides. 1, 2, 3, 4, 5. So we have this one arc here, another arc here, another arc here, another arc. We can do it like that to 6. That's hexagon. When we enter that, this is, you understand what we're talking about. So this is an arc. Right? The line like this is the chord. Are you understanding me? So now the third cycle is talking about sector. We now draw the line to form a chord. Just a particular part of the circle, which is called sector. We used to form an angle, and we derive the sector from there. I understand what I'm saying? It has no chord. It only has 2 radius. Are you understanding me? So now, when we want to use the formula, you can see I draw it out now. This is sector. You understand what I'm saying? Wait a minute. This area of the sector. But the way we draw out an arc, yeah, this line is. So we look at this. We have length of an arc. Look at it very well. S is equal to what? Of what? An arc. That is from here to this place. That's length. That's the S, the length. Now, it now has two radius. How many radius? And what angle does it have? Angle theta. This is called what? Say theta. We call it theta. It's a Greek language. A Greek language, a Greek letter for TH. For what? Are you understanding me? So, but we use it to denote angle. I do tell people don't know that as a science student, you are solving the Bible. You are not. Because each letter in the New Testament is what you use to represent different kind of let's say angular velocity, let's say theta angle, all these stuffs. You are using Greek letter to represent those things, those measurements. Are you understand what I'm saying? So theta is Greek letter for TH. So we use it to denote angle. Anyway, you see theta is talking about what? Angle. Other letter in the Greek alphabet they use for another thing. But by the time we get there, you understand. Let's say like alpha. We call it coefficient of static friction. When you are doing latent heat, coefficient of latent heat, you see all those things there. They use those letters. When you're doing radioactivity, alpha, beta, gamma, they use those Greek alphabets. Are you understand what I'm saying? But for angle, mostly, you see theta. Anywhere you see theta, it's talking about angle. Now, the formula is now, if you now want to look for this length from here to here, you're not going to say S, which is the length of the arc, is equal to theta over 360 times 2 pi r. What does it mean? Let me explain one after the other. Look at it very well. This theta denotes this angle. Where did we get 360? Total number of the side of angle of what? Of a circle. That's 360 degrees. Are you understanding me? Now, where did we get this pi? I'm not talking about pi. When I say pi, pi is a what? What is pi? Let me ask you. What's pi? That is a constant which we denote as 20 over what? 7. How did we get 20 over 7? There's a man called, this man is called Galileo Galilei. He did a lot of experiments. What I got him in Italy, he climbed a particular tower. Are you understanding? So he now do equation on a pendulum. Are you understand what I'm saying? So he now from there manipulates the calculation. You understand what I'm saying? So from that, the way the sun at one angle show the distance. So he now kind of observe the ray of the sun. He now go to another place. That's that form angle. So he now calculate it. That's why we have 22 over what? 7. In decimal places we have 3.1423. It is very long, very long. But they approximate to 3.142. I understand what I'm saying. But this is the number is very, very long to get a time. So he was able to use a watchtower to get the angle of the reflection of the sun. From there, he was able to now get what's called pi. You know what I'm saying? He was able to get pi. This pi. So pi is close to 22 over what? 7. Are you seeing it from there? 22 over what? 7. So now, let's say, are you done with this? Right on this, I will speak with this. Come on, wipe this side so that I will explain this. Don't do it on the side. Now look at this. So we have x, the length of an arc is equal to theta over 360 times 2 pi r. Let's arrange again. Theta over 360 times 2 times 22 over what? 7 times r times the radius. Are you seeing this on there?
Yes.
Good. Now from here now, so let's say theta is equal to 30 degrees. Radius is equal to 10 centimeters. So if you want to get the length of this arc, what are we going to do? We're going to say our s, the length, is equal to what? 30 over what? 360 times what? 2 times 22 over 7 times what? 0 cancel 0. That also 3 here 1, 3 here 1, 3 here 2. That's 12. Are you seeing it? 2 here 1, 2 here 6. That also 2 here 3, 2 here 11. That also. So what will remain? S is equal to 11 times 10 over what?
7.
It's not 7, it's 3 over 3. You forgot it's 3 now, it's 3. 11 times 10, 11 times 10 over what? Over 3. Huh? What is it?
The 7 is 7.
Okay, sorry. 3 times what? 7, thank you. It's equal to 11 times, this is equal to 110, right?
Yes.
Over 20, 21. So you can use your calculator there. And 3 goes 11. Eh? It remains 2. So we are going to result into SC. Are you understand? We are going to result into SC. So if we are to do that, because of our time, you can use calculator. You can use calculator. Hmm? 5 points. Continue. Another person? Another person. Let's look at it. It is actually 5.23. What it means? Is this sentence? 21 times 5. That's close to 105. So it's 105. Okay. It's close to 5.22. So write it down. Let's do one or two things before we call it to go. This I thought was not happening. This one. Are you participating? Are you participating?
Yes.
Are you understanding? I hope you are not saying yes or yes or no. If there's any question, ask question. So you don't be left behind. So you don't be on your own. Are you understanding?
Yes.
Good. The next one, let me look for another question. The length of an arc of a radius 7 cm is 12 here. The length What do you notice here? The length of an arc of a circle of radius 7 cm is 12 cm. Find the angle which this arc subtends. at the center of the circle. What does it mean? Look at it. Look at it. What are those things they give us? The length of an arc. We are being given S, right?
Yes.
We are being given S, right? Good. S is close to what? What is our S?
S is first.
12. What's our S?
First.
You want to say 7? This is what is called how to answer question that I've been telling you. How to what?
Answer question.
Good. So that you don't be confused. Look at it very well. They say the length of an arc of circle of a radius 7 centimeter is, they gave me a radius to be what? The length is what? So you should understand the question. If you don't understand the question, you just say, okay, they say the length of an arc of a circle of a radius 7 centimeter is 12 centimeter. You just think that the length of an arc is what? 7 centimeter, and you are on your own. Once you just go and miss that step, say error. That's it. That's just it. That's how a lot of people they fail. Why can jam? Because they didn't know how to answer question. They will not listen. They will just read and they will go and write rubbish down. So once you understand the question, you know that this is how I will position my formula, and this is how I will fill in this formula one after the other. Now, I said the length of an arc of a circle of radius, the radius is what? 7 centimeter. So that length that they have been talking about is what? 12. So my S is equal to what? 12. Are you understanding me? Now the radius is what? Is what? Now they say find the angle. What am I looking for? Theta. I don't know. I don't know theta. The angle. Find the angle which this arc subtends at the center of the circle. They give me pi too. To be what? Can you see that? The question is what? Yes or no?
Yes.
So what is the formula? Without looking at the book.
Theta over 360 times.
S is equal to what?
Theta over 360 times 2 pi r.
So what am I going to do? What is my S?
12.
I'm looking for my what? Times 2 times 22 over 7 times 7. Times what? Are you seeing it? 2 times 7. So what am I going to do here?
You cancel.
7 times 7. Are you seeing it? This one can come here. 12 times what? 360. It's equals to what? 2 times 22. 44 theta. Is that not so?
Yes, sir.
So divide both sides by 44. You have 12 times 360 all over what? 44. It's equals to what? My theta. So yeah. Now 2 here 22. 2 here 6. 2 here 11. 2 here 3. So we have discussed to 3 times 360 all over what? All over 11. We have multiply and divide.
That's
Eh? That is the way we can do it too. 360 times what? 3, right? 0. 3 times 6, 18, right? 3 times 3 plus 1. So 1080 divided by what? So you can do it, divide it to give us the decimal. Yeah, just so. Once you get the decimal, you get the angle. Everybody look up. After solving this equation now, you know what I'm saying? After solving this equation, you get the angle. We can represent this thing now on the paper. Look at it. And now this one is a measuring rule. You know what I'm saying? Because it is in the form of a semicircle. So we can represent this thing now. You just say, what is the theta? You want to get the angle, divide it to get the angle. You just look at here. Look at it. Look at this case. What do you see? Good. So an arc, angle 90, right? You see from here to here, angle 90. It goes again to the other angle. You know this angle, this is angle 180, 180 degrees. Everything is 180 degrees. So you can say this one now is a diameter. Is that not so?
Yes.
So we can represent this like just a plate. You can just choose this one. You just put this rule on the paper, set this angle. There's something that we should put on this to loosen it. You can use all this too. Spanner, use it. I'll set the angle. That's what I'm saying. You have to set the angle. You now draw the line. After drawing the line, draw the angle using compass. You understand what I'm saying? So maybe the angle is this thing. Let's say angle 40 or angle 50 or angle 30. You use this to draw the angle. So from that angle, you use your compass. You use this to direct the radius. Draw the two line. Once you get the angle like this, let's say angle 30, you get the angle. You now use this rule to draw the line from the center of that angle. Are you understanding me? So it will now be the two radius, another radius here, another radius here. You understand what I'm saying? So once you align the radius, you just use the compass to cover to draw the arc. Are you understanding me?
Yes.
That's what we do in technical drawing. So we calculate for the angle. After calculating for the angle, the radius, you have been given the radius, you just draw it out. It's going to be perfectly aligned. What did I say? Perfectly aligned. Anyone have to, maybe you want to study mechanical engineering, you have to understand mathematics. That's what I'm saying. So you want to study elect, you have to understand mathematics. But these are the things that you're going to use. Or you want to study civil engineering, construction, all this stuff. You have to understand this mathematics. So you will not be able to put everything to be in order. It will align perfectly. I understand what I'm saying? That's how they build a lot of massive structure. Have you been to Ikoyi before? Have you been to Lekki Aja? What about this place? Victoria Island. You see some massive building. If you see the architectural design before they start those building, everything will be perfect. You understand what I'm saying? So they will do a lot of calculation. Don't worry, I will bring one of those. I'll bring one of those planning. I have a lot of it. You see the alignment. By the time they now use to build a house, you understand what I'm saying? It should be perfectly aligned because they've done a lot of calculation. You understand what I'm saying? So everything you see in this world, even in the universe, is under calculation. Serious calculation. Have you gotten the decimal point? You gotta bring out the last one. That's what this maker of a tablet. I think they do calculation of this. I don't think they do any calculation. There's no calculator. I bring my last one. I need it. They have to use calculator. There's no calculator. Once you might know, you need to go and get those scientific calculator. Just mind. And I went there to do something.
98.8.
Eh?
98.8.
You to do it. Is it correct? Eh? Nineteen point 18. Who got it? Now for him. Let's go to 19 point what? 0.2 degree. Are you done? So 98.2 degree. So come on, back this piece. So I'll do one or two things before we call it. Okay. So let's do the next one. That is a second minor second. Let me actually call it again. What do I call it?
Minor sector.
Minor second. There's a question here that I want us to. Woo! There's something that is begging. Before we use it, there's this question that's. Please, let me see. I'll just find a way to set this question for you. But not today. You understand? It's something you can describe. It's something you can do it. Eh? So board mass and board. Have you been taught board mass? I'm not doing all this one, but I've not been doing it. Yes. This is good. Anyway, you find a time to do justice to that. There's a question begging for an answer here. The question goes to us.
How over 45 equals
Yes, yes. Hello. Hello, students.
Yes, sir.
You have to pay serious attention. Let me move the caption, please. Where is that? Do you see it at the back? No, no, no. Put it in this way. Put it in. Don't rush it. Assistant of the Assistant of the later you wash it. Hello? Everybody pay attention to this very powerful question. A sector of a circle of radius 7 centimeter subtends an angle of 300 degrees at the center of the circle. If this sector is bent to form a cone, find the radius of the base of the cone and its vertical angle. What does it mean? You tear a sheet of paper. You know what I'm saying? You draw a line like this. You draw a line like this. So this is the sector. Used to form a cone. Are you understanding me? You know, you can remember this formula, minus sector. This is like this. So now you now fold it, you need to form what? A cone. So there will be vertical line here. There will be radius here. Are you understanding? So you bent the sector to form what? A cone. You know cone. That's the small one used to put it there. Now under that thing, it will have a radius. Now this one is like a circle now. So this kind of circle is called spherical circle. Look at it. Not totally circle, but it's like a circle. Now under it, it will have radius too. From here to here, that will be radius. From here to here, that's another radius. We'll do the two radius together, that's diameter. Now, here's the vertical line from that cone to the base of the listing. So this one now is also a radius. The main radius. Are you understanding me?
Yes, please.
The main radius. Let's try it. 6.